Okay, hello. So this is the sixth video, I think. The sixth one. Yep, sixth one. What I'm going to do in this particular video is going to be, I'll be discussing combinations of capacitors. All right. So let's look at what we have. We have problem one. Right, we have two capacitors in series, and for the figure shown, determine the effective capacitance and the voltage across each capacitor if a 6 volts DC power supply is connected between A and B. Okay, so our first task is actually to find the effective capacitance. Now, just to remind you that the effective capacitance, if these two are in series, are going to be 1 over 6 mu plus 1 over 4 mu, right? Then invert that, inverse that, right? So what you're going to get from there is 2.4 mu farad. So that's your effective capacitance. Okay, there we go. Okay, now we want to move on to the second part, which is the voltage across each capacitor. Okay, now the voltage for the 6 mu farad is going to be different than the voltage across the 4 mu farad. Okay, but their charges are going to be the same. The charges across them are going to be the same. So what I want to do is I want to look for the total charge first, right? And this is going to be effective capacitance times voltage across A and B. Okay, so my effective capacitance is 2.4 times 10 to the negative 6. Then my voltage is 6. And that would give me a value of 14.4 times 10 power of negative 6 coulomb. Once I have that, then I can find the voltage across, let's see, voltage across the 6 mu farad as well as the voltage across the 4 mu farad. And all I need to do is divide Q total, right, by the capacitor of the 6 mu farad. So that means I'm going to have 14.4 mu over 6 mu, right? I can just cancel out the mu's. What I'm left with is 2.4 volts, right? And the same goes for the 4 mu farad, which is just 14.4 mu over sorry, not 6, but it should be 4 mu, which leaves me with 3.6. A quick check is that these two when added should give me 6. If I add 2.4 to 3.6, I'm going to leave with 6. So they're both the same. All right, so that is for problem 1. After this, we're going to look at what happens if they're parallel. Okay, so in this problem 2, what we're looking for is a bit different than the previous one. So here we have the capacitors in parallel. Okay, if they are in parallel, that means their voltages are going to be the same. Okay, so voltage across the 4 mu and the voltage across 6 mu farads are going to be the same. So instead, what they're going to ask for is charge stored. Okay, so let's just look for the effective capacitance. The effective capacitance is simply going to be 4 mu farad plus 6 mu farads, which means it's going to be 10 mu farad. That's all there is. Okay, so for capacitors in parallel, their capacitance is just added up together to get the effective capacitance. Okay, right. Now, if we look at the charge, so I have Q equals to CV. Because the voltages are all the same, I can quite quickly calculate the charge stored. So let's say I want to look for the charge stored in the 6 mu farad capacitor. Then I can simply put, okay, 6 mu for the capacitance and 6 for the voltage. So that leaves me with 36 mu coulomb of charge. And then if I'm looking for the 4 microfarad, that would give me 4 mu times 6, which is 24 mu coulomb. If I were to just check, right, if I just to make a check here, if I calculate the Q total, which is equals to C effective times V, right, C effective is 10 mu, V is 6 volts. So that means there should be a total of 60 microcoulomb of charge. And if we see 36 plus 24 definitely gives 60 microcoulomb. So these two numbers match. And therefore I can say that this is my final answer for the effective capacitance, and this are my answers, right, final answers for the charge stored in each capacitor, right? So this is just a good check, a good quick check, right? 60 microcoulomb, just to show that, okay, my answers make sense, nothing is out of the ordinary. Okay, so we are looking at problem 3, the third problem. We've covered series and parallel, and now we want to look at the combination of them, right? Okay, so let's look at the question. We have 3 capacitors, and then the question goes, for the figure shown, determine the effective capacitance and the voltage across the 4 microfarad capacitor if a 6 volt DC power supply is connected between A and B. Okay, so let's look at what we have. If I were to just combine, let's see, if we were to just combine the 9 and the 3 microfarad, we can find, we can convert this particular part of the circuit to become something that looks like this. Okay, so here we still have our 4 microfarad, and then we have something in the middle. All right, so let's call this C9, 4, and because they're parallel to each other, what we can say is that it's going to be 9 microfarad plus 3 microfarads, which is going to be 12 microfarad. So now I'm left with 12 microfarads and a 4 microfarad capacitor in series. Okay, so now what I can do is I can find the effective capacitance overall, remembering that if in series I will have to have inverses. So I have 12 microfarad plus 1 over 4 microfarad, and then inverse that, and that means my effective capacitance is going to be 3 microfarad. That is my final answer for the first part, effective capacitance. Okay, just gonna tick that over there. All right, so now comes the bit more difficult part, which is the voltage across the 4 microfarad. I'm just going to use green, voltage across the 4 microfarad. Okay, so what we can do is we can figure out what is the total charge first. So let's find the total charge. It is simply going to be the C effective multiplied by the voltage. So my QT is 3 microfarads times 6, which means I have a total charge of 18 microcoulomb. That's the first thing. So that means if we look at our second diagram, I have 18 microcoulomb going through both the capacitors. Okay, so once I know that, it becomes quite easy to figure out what's the voltage across the 4 microfarad capacitor, simply by taking QT and dividing it by the capacitor of the 4 microfarad. All right, so then I have 18 microcoulomb over 4 microfarads. The multiples of 10 to the power of -6 just cancels out, and I'm left with 4.5 volts. Okay, now just to check, right, let me just change colors here. This is something I do just to check something, right? Checking, let me just label that. This is a check. If I take the 12 microfarad and I figure out what's the voltage across them, so QT over C 12 microfarad, I'm left with 18 over 12 microfarad. Then I will have 1.5 volts, and 4.5 plus 1.5 is in fact equal to 6 volts, which matches with our value here, right? So then we have already found the voltage across the 4 microfarad capacitor. So the answers for the question is that the effective capacitance is 3 microfarad and the voltage across the 4 microfarad capacitor is 4.5 volts. Okay. Of course, from time to time, I like to just remind students to just box your final answer so it's easier for the marker to check. All right. Okay, so now we move on to problem 4. Okay, so we are at problem 4, which is going to be the last problem in this video. So let's just begin by reading the question. For the figure shown, determine the effective capacitance and the voltage across the 4 microfarad capacitor if a 6 volts DC power supply is connected between A and B. Okay, so I guess the first thing you want to do is actually to find the effective capacitance. So let's look for the effective capacitance. So what I want to do is I want to simplify this circuit. If I simplify the circuit, what I can do is I can have 2 capacitors in parallel instead. So let's call this combination of 9, 4, right? Then I have 3 microfarad here. And this seems to be much easier to solve because this would be in parallel. So let's look at 9 and 4. They are in series. So then I can write down here 9, 4, the capacity combination, capacitor combination is simply going to be 1 over 9 mu plus 1 over 4 mu, and then inverse that. And what I'm left with is approximately 2.77 mu farad, right? And then of course I can just add them up. I will have effective capacitance of 2.77 microfarads plus 3 microfarad, which gives me a final answer of 5.77 microfarad, and that's my answer for the first part. Okay, my answer for the first part of the effective capacitance done. All right. So now what I want to do is I want to look at the second part, which is the voltage across the 4 microfarad. The good thing about this problem, let me just write down from the top here, is that the voltage across 9, 4, the combination of this one, is going to be equal to the voltage total, which is equal to the voltage of 3 mu farad. Okay, that's the nice part about it. So what I can do is I can figure out what is the charge across C94. So that means I'm going to have charge across Q94. Okay. So C9, 4 equals to V, which is just 6. Okay, 9, 4. So then my Q9, 4 is simply going to be 2.77 mu multiplied by 6. And this gives me an answer of 16.62 microcoulomb. Okay, so if I were to look for the voltage across the 4 microfarad capacitor, I quite simply can do it just by dividing Q94 by C4 microcoulomb. Okay, then I have 16.62 microcoulomb over 4 microfarad, and that leaves me with the voltage across the 4 microfarad capacitor to be approximately 4.15 volts, and that is my final answer. All right. Okay, there we go. Those are my two final answers, where I have the effective capacitance to be 5.77 microfarads, and the voltage across the 4 microfarad capacitor to be 4.15 volts. Okay, that is all from me. I'll see you in the next video. Thank you very much.